everybody. My name is Yohann Bauzil. I'm Chief Security Officer at LookUp Space, and I'm really glad to be here with you today. As you can hear to my accent, I don't come from London, but directly from Toulouse. Today we are going to talk about digital challenges and cyber locks on our product called SYNAPSE, a product specialized in space situational awareness. The presentation will be divided in 3 parts. In the first part, I will introduce the topic and talk about the cyber locks. On the second part, Anna Barraqué from CYSEC will have a focus on a dedicated lock. And on the third part, I think you will have some questions, and I hope we will have some answers. Okay. So, need and willingness. Is there a problem today in space? The answer is yes. Today we can count something like 1 million objects, between 1 centimeter and 10 centimeters, and something like 100 million objects more than 1 millimeters. There is a real topic on this regarding a threat for safety and security of space operation. Is there a solution? Yes, because there is a strong political willingness on the topic. In 2022, Mr. Emmanuel Macron and Mr. Thierry Breton talk about that. And one of the solutions is LookUp Space. Today, the ambition of LookUp Space is quite clear. We want to give an strategic autonomy to Europe regarding security of space situational awareness. The company has been founded by our 2 co-founders, well-known figure in space domain. The first one is Juan Carlos Dolado Perez, who was former head of space situational awareness at CNES. And the second one is General Michel Friedling, who was the first French space commander. Our goal today is quite simple. We want to support all the space operation and all the mission. If we take an example, for example, inspection, today there are a lot of companies who have a business case which is to take some picture of other spacecraft. When you want to do this, you need to have high quality and high accuracy information to plan a rendezvous. Or you have a chance to destroy both spacecraft. So that's why we are going to work on this. Our project is based on 3 pillars. The first one is called SORASIS. It's a network of ground-based radar all around the world. It's a difficult industrial information system. We have to manage it and also to cyber protect it. The second pillar is SYNAPSE. It's our digital architecture. It's a cloud-based information system. We need to manage it and to cyber protect it also. And the third one is SYNAPSE as a service. We have a lot of experts in the company regarding space situational awareness. They are working on a proprietary algorithm, and they are working on our corporate network. So we also have an important corporate network to protect. If we dive a little bit more in the concept, how SYNAPSE is working, on the first step, we have to collect data. It can come from different sources. The first one, for sure, is our radar, SORASIS, but also from OSINT or external sources. When we have this data, we after have to process the data. We apply some proprietary algorithm to the data, and the goal is to enrich and to have information and even intelligence regarding all the data we have. On the third part, when value is added, we can propose some services to our client. We can talk about collision avoidance, maneuver detection. And our clients are space agencies, Ministry of Defense, but also constellation operator or launch companies. If we dive now into the technical part, here are our 5 main, let's say, digital challenges and cyber rocks. The first one is the need to know. We may have some dual use information on the platform, so we have to take care of this part. The second one is the real-time performance. We have a lot of information. After the modularity and the scalability, and finally the hardening, where I will introduce the partnership with CYSEC. And if there is a cyber lock, there is always a cyber key. If we have a focus on each lock and challenges now, the first one, as I said, is the need to know. We have some data, we have some users, and the strategy which has been chosen was an ABAC approach. The idea is quite simple. You apply some label to the user, you apply some label to the data, and after you have access rules between both user and data. Regarding the real-time performance, we have to fuse a lot of sources. We also have different need, and it has been chosen to use technologies around big data to do this job, and also with a buzzword to have algorithm based on artificial intelligence. Sorry. Regarding modularity and scalability, for modularity, we want that our architecture is the most independent as possible as the physical infrastructure. Sorry. So the idea was to work with Kubernetes, and we choose to use a platform as a service provided by Thales and called CAST. Regarding scalability, for this platform, it was difficult to not have to move to cloud. So now we have to deal with all the topic around the cost, for example, but also the topic around security, sovereignty also. That's why we use only French sovereign cloud, and for sure cloud which are qualified as a second cloud. And for the last lock, it's the hardening, which is the most important, especially for a security guy. We have a need to have a strong confidentiality regarding our data, so we need to protect all our data in transit, at rest, and in use. And in a strategy of make or buy, we have chosen to create a partnership with CYSEC, with a specialist in this kind of need. As a mid-conclusion, if we take each one of the lock by itself, it may be simple, but when we take all together, all at the same time, it's another story. I will give the dance floor to Anna. We will introduce the CYSEC part.
Thank you, Yohann. So indeed, hello everyone. I'm Anna Barraqué, and I am product manager at CYSEC, and specifically for this SYNAPSE project, I'm also managing this project. So just to start a bit, you might know CYSEC. We organized this event, CYSAT, that I hope you're all enjoying, and we have so 3 lines of product. The first line of product is ArcaSat Link, which encrypts and authenticates TMTC, so between the ground and satellite. The second one is ArcaSatcom, so it will encrypt and accelerate SATCOM frames, so between 2 Earth users and the satellite is only a relay point. And thirdly, and this is the topic of today, we have Arca Trusted OS, so our hardened operating system. So if we go and we think that we're LookUp space, what is the question that we want to solve with Arca Trusted OS? This question is, how can I trust an infrastructure that I do not own or control, but in which I will deploy my sensitive data that is at the core of my business? And how do we do that? We created Arca Trusted OS. So what is it? It is a container-specific, Linux-based micro-distribution operating system, as you can see here on the scheme. And so it is a mostly read-only operating system. So this is the first layer of security, and then we come and we harden it with 3 other components. So first, we do full disk encryption by default. Then we also have a secure boot. This means that when we want to launch our VM, we will check at each stage and for each component that it is at the good configuration with the right version and different parameters, and make sure that no one else came as an intrusion and tweaked some parameters that could then be a security breach for us. So once this secure boot has been done, then we can start and launch the VM. A third hardening that we do is something called confidential computing. And what this means is that we will create around the CPU a trusted environment where we will also encrypt the data in the RAM memory. So with this said, we can deploy Arca Trusted OS on-premise, on the cloud, at the edge. But for this SYNAPSE project, of course, we will deploy it on the cloud. So how does it look like on the cloud? You can see it here. And we have a completely isolated VM from other cloud service providers, administrators, or other VMs that are running on the same cloud service provider. And what we add as an additional feature is the remote attestation. Imagine we are doing a cloud service provider that might be not sovereign, and so we don't want to trust this hardware with our keys. So what we will do is that we will put our keys in the Arca verifier, and once we have done the check of the secure boot and making sure that our environment is secure and that we can trust it, then we will go to the verifier and get the keys to be able to launch the VM. So this, of course, gives more confidentiality and authenticity to the service we provide. And to put it more in a perspective, here is a scheme of all the components on which the security is based for a normal cloud service provider without Arca Trusted OS. So you see that, of course, you have the VM that's running, but you have also all the layers from the cloud service provider, and as well as all the applications that run on top of it. When we put Arca Trusted OS, this is what we get. So we have our VM that is completely isolated from the different layers underneath or above. Of course, we do need the CPU. And we have the verifier, so on-premise, that we'll store our keys. Meanwhile, we check that we trust the environment. So, as a conclusion, this is what the platform will look like. So, of course, the security is completely transparent, and it will not impact the performance of the platform. Here you can see, as Yohann explained, that you have the different space assets as well as the result of their computation that will run on the isolated VM, having some risks, threats, and collisions probabilities. So thank you very much for your attention, and if you have any questions, we'll be pleased to answer them.
Oh, thank you both for another brilliant presentation. So we've got the code up here and the QR code as well. So if anyone wants to upload some questions online, and I can read them out for you. Are there any questions in the room?
I guess the presentation was clear.
So brilliant that they know everything about it now.
Great.
I guess, is this already in deployment?
So yeah, this is a project. So we're working on the deployment. There has already been some prototypes deployments, and of course this will continue going until their service is full on running, and yes, it's a continuous project.
Oh, wonderful. I can see that there is there a question over there? In the far corner? Not one that I can see. Okay, one that's online. Let me see if I can bring it up for you. Hey, you've got a question here. How does your automated collision avoidance system tackle the challenge of agreeing between different satellite operators who have to carry out a collision avoidance maneuver? Who wants to take that one?
Oh, very good question. Now, to be clear, I'm a Chief Security Officer. This is mainly a business question. So if you want, we have a booth on the startup corner. You can come and we can discuss with my joker, but this is very difficult for me.
Okay, that's an offer for a more detailed conversation at the store. I'm just looking and I can't see any additional questions online. Has anyone had any thoughts in the room? Yeah.
Thank you for the presentation. This is a question about the hardening of the ARCA verifier. What about that?
What do you exactly mean by the hardening of the? I mean, I can go deeper in
how
depth.
you can secure this ARCA verifier in order that there is no security hole with that product.
Yeah. So the ARCA verifier, so it's held on-prem. So of course the idea is to make sure that the client or the partner has a secure server, and then what we usually do is that we have either HSMs or TPMs that would be FIPS or Common Criteria certified to store the keys. And then we have the communication between the verifier and the guest VM. We have a TLS 1.3, so secure channel, in which we will exchange the keys. And as I said previously, so we wait first that the entire environment in the cloud service provider is secure. We will then send, so from the verifier to the guest VM, so a challenger nonce, that then will be used to sign the attested secure boot certification. And this will be used then by the verifier to make sure that the key used is the correct one and that the environment can be trusted. If that answers your question.
Oh, thank you for that question. Are there any others? Yeah.
I have a question. How do you ensure the integrity of what you deliver to the client? So you mentioned confidential computing, hardening, but I think that there is maybe also a constraint about the integrity and authenticity of what you can deliver. So did you focus on this aspect also?
Yes, so when we do the secure boot, of course there is the integrity factor that we check that everything has been unmodified when we generate the certificates to that ensure that the environment is trusted. If that answers your question.
Oh, thank you. Are there other questions? Oh, I can see some more at the back. Where are you?
Yes, you mentioned, especially for the confidential computing part, that you would support having the data in the RAM encrypted. And I'm wondering, at which point will the data in the RAM be decrypted again to be used for the computation, and where would the keys be stored for this?
So the keys that used for the confidential computing are keys that are randomly generated by the CPU.
So that means it's supported by the hardware in that case.
Yep,
Okay,
the
thank you.
CPU. That's when you saw the stack. That's when we had the yellow box with the CPU that we do trust.
Cool. Are there any other questions? Oh, I can see another.
I don't know if this will be a business question again, but if there are many organizations that are doing space situational awareness, and there is a certain level of overlap, and some of it is primary and others other sources of data. How do you differentiate between the two so that you have your own ground truth that is not fake data from somewhere else or injected data? How do you take care of that?
I have a magic answer. We have a booth in the corner. If you want to come, I will be very glad to have a specific discussion on this topic. Thank you.